All right. Thank you. How are you all doing today? Doing good? Let's hear it. You guys doing good? All right. All right. Thank you to all of the volunteers and the staff and the team that have put together BSidesAugusta. This is definitely one of the events that I looked forward to every year. So thanks again to all of you who have put work into this. My name is Josh Brower. I've been doing IT since my teens. Been involved in InfoSec the last 10 years and endpoint and network detection as the focus of that as well. Today we're going to be talking about an app called Osquery. Has anybody heard of Osquery before this talk or before yesterday at the Security Island Conference? Okay, a couple, maybe half the room. Is anybody using Osquery on a regular basis, especially in your professional work? So I have a couple. Great, yes, the guy with the Osquery shirt. Thank you. All right, good. So Osquery, we're going to be talking in this very short talk. We're going to talk a little bit about what Osquery is, an introduction to it. Those of you at the SO talk will just have a little bit of redundancy there. But then we're going to talk about how to use Osquery, the interactive shell, to interrogate a Windows 10 system. And we'll look at how to do that with a demo that hopefully should work today. All right? So let's get started. Live interrogation with Osquery. We can do this. We have the technology. There we go. May have to stand over here. So Osquery is an open source application. It was released by the Facebook team back in 2014. It allows you, once you install it on your system, it allows you to query your system as if it's a relational database. Okay, for instance, if you want to look at all of the users, the local users on your system, once you install it, you can say select star from users semicolon, and it gives you all of the users on the system as well as metadata about it. Okay, so it's open source. It allows you to use SQL syntax with it. And finally, it's cross-platform. It has a wide range of support for most of the Linuxes out there, as well as the BSDs, Mac OS, and Windows. Lots and lots of support across all the different platforms. And let's see how we can use this practically in a recent issue. I think it happened about 6 weeks ago. I just come over here and manually tap it. There we go. Anybody familiar with this? The Mega Chrome extension that got compromised about 6 weeks ago. Okay, the Mega Chrome extension has about 2 million users, and what happened is the latest version was sending credentials for Amazon. I think it was GitHub, Google, and Microsoft. Okay, now if you're in this situation and you want to know if any of your users on your network, on your systems, has this compromised extension installed, here's what we can do with Osquery. We can look at the different tables that Osquery has. If you go to the Osquery website, osquery.io/schema, there are over 220 tables that are available. Each of these tables allow you to look at a certain part of the system. I already mentioned the users table. There's a couple, quite a few up there that you can see. You can look at under Mac OS Xprotect. You can see the logs related to Xprotect. Cron jobs, lots and lots of different tables. Fortunately for us, there is a Chrome extensions table. It is Chrome underscore extensions, and you can see the different columns up here. These are, and there's quite a few others that aren't actually listed. In the upper right-hand corner, we also have what are the different platforms that are supported for this table, and in this case, it's all of the major platforms. So to build a simple query, we're going to say, select the user ID column, the name column, and the identifier column from the Chrome extensions table. Now, each Chrome extension has a unique identifier. If you go to the Chrome extension store, look up the Chrome extension, the identifier will be within the URL, so you'll be able to easily identify a Chrome extension by this identifier, okay? So when we run this, we will get something like this. May not be very readable. We have the user ID 501 on the left-hand side, the name of the extension, version number, and the identifier that I just mentioned. This is great. We got all of our extensions right, but if we have lots of users and hundreds of extensions to go through, that's not very practical for us to try to manually extract out is a mega extension in there. So next we're going to edit our query. We're going to add a filter clause. We're going to say select the user ID, name, identifier from the Chrome extensions table. We're going to say where the identifier is the mega extension identifier, and the version number is the compromised version number, version 339.4, okay? Now I also have that last filter crossed out because when you're in this kind of a scenario, you'll also want to run this query from the perspective of, okay, is there anybody that currently has the compromised version installed? But is there anybody that has the extension installed, period, in case it updates to the compromised version? We want to know if anybody has it installed, period, right? So there's two different options there. So what we'll do, the results we get back, we do see a user that has this Chrome extension installed, okay? This is good. We know somebody has it, but we don't know the username. We just have a user ID, which is not very helpful for us humans. We need to be able to identify this user somehow. And this query only gets the Chrome extensions for the current user. So we want to get, if we're, let's say, looking at a Windows terminal server, we want to look at all the different users that are on the box. And to do that, we're going to join the Chrome extensions table with the users table. This is our final query here. We're going to say select the users.username, Chrome extensions.name, Chrome extensions.version from the users table. We're going to cross-join that with the Chrome extensions table using the common column user ID. All right, now to those of you who don't have a background in SQL, this probably looks like gobbledygook and doesn't mean much to you, and that's okay. I think that's actually one of the major benefits of Osquery. If you want to use Osquery, you don't need to learn an esoteric proprietary query language. You can go out and find free, low-cost quality training for SQL, and you can take what you learned and implement it right there with Osquery. Now, those of you who are familiar with SQL, you may be wondering why we're using a cross-join. In this particular instance, it just works more consistently with this table, which is why we're using the cross-join. All right? So this gives us the result of, we have Dresden and Everett, so that converted the user IDs to the usernames. And then we do see that we have 2 mega extensions installed, and they're both the compromised version, okay? Is that making sense so far? A little bit. I'm seeing quite a few. Okay, good. This is good. All right. So from here, just before, we're going to go ahead and look at our demo. Let's talk about Osquery I and Osquery D. There are 2 components to Osquery, the interactive shell and the daemon. Which do you think is which? Someone answer. Come on. Yes. You got it. Which one is that? The interactive shell? Yes, good job. Man, we need to give this guy a prize. Do we have any prizes? Okay. Does he just get to pick? Okay. Come on up, and why don't you grab yourself a prize. We have 3 different prizes, all right? Thank you for being the one that answered the question. I appreciate it. You can just come on right on back and grab yourself something. All right. So there's 2 components, Osquery I and Osquery D. Osquery D, the daemon version, you run in the background on your endpoints, and we'll talk about it a little bit later if we have time. We can schedule queries against it and send those logs elsewhere. Osquery I, the interactive shell, we'll see in just a minute. We drop it on a system. We can interactively use Osquery to query the system. I just need to make a note there because when we talk about Osquery, people talk about one or the other, and it's not always clear what we're doing. So right now we're going to drop into Osquery I. What did you end up getting? That looks pretty good. A wireless adapter. Okay. I think I got that one a couple years ago. It's good. I'm sure it's a new one, right? A new version. All right, so let's jump to the demo. Here's a scenario. You are a tech for a local company, and you got a call from a user who says that they go to Office 365 in their browser and they're getting a weird error. Okay, so you go to the Windows 10 system, you can see you have some apps installed. You bring up their browser, you can see that if we go to portal.office.com, which is the entry point to Office 365, we get this odd 404 website not found error. Okay, so from here we can open up a elevated PowerShell session. We can run Osquery I, and this is the interactive shell. Now, before we start, just from like the 10 seconds of context I gave you about Office, portal.office.com, any ideas on what it could be? I just want to take some ideas. Any ideas on, you're going to portal.office.com, you're getting this weird like 404 error. It's working on other people's machines. Any ideas on what could be wrong with this system just from that little information? Yes? Okay, so DNS resolution, okay? So that's definitely an interesting one to look. Yes, back here. I'm sorry? Okay, host file, great. Another one, so we have DNS, host file, yes. Browser extensions, okay, good. Good, so 3, any others? Back there. No network access? Yeah, well, okay, let's pretend that we have network access, but good call, okay? All right, so those are some good ideas, right? So what we could do, we could just go ahead and start looking at those specific areas, or the way that I typically like to start is look at what's a running process, what processes are running on the system. So let's start looking at what processes are running, and then we'll go from there. If I'm in the interactive shell, I can say .version. If I can type right, I'm always horrible typing. Probably going to take an extra 5 minutes just because of that. All right, .version. So you can see we're running Osquery version 3.3.1, okay? So we're going to query the processes table. And if you use Osquery and you can never remember what columns are available in a particular table, you can use this handy little command. It says .schema and the processes table. And that will show you the schema for the processes table. You can get the column as well as the column type. All right, so in this case, there's a process ID, there's the name, the path, the command line. We're going to start with a couple of those. We'll say select the process ID and the path from processes. Typically, I would start with process ID, path, and command line. But because we have a lack of space, we'll just start with those two and go from there. So we run that. We can see that there are quite a few processes that are running, and it's not really even formatted that great, and it's kind of hard to look through, right? So we should go ahead and filter this down a little bit so we can look at the processes, make it a little bit easier. So we'll say select the process ID path from processes where the path is not like, and we'll say anything outside of C Windows. So this is pretty arbitrary, but what I like to do is split, when I'm looking at processes, split it in an arbitrary way so that you can make it easier to filter out and look at the different processes. So right now, we're filtering out all the processes that are inside C Windows, and then we can flip that around and filter for everything that's inside C Windows. So when we run that, we'll see that there are a lot less. We have a bunch of Chrome processes. You know, there's a lot less. I will say that in my preview, excuse me, when I was working on this demo previously, I didn't have quite the issue with the screen, so it's a little bit harder to read right now because I have it so big, but let's just deal with it. Is there anything right now that we should look at a little closer? Just from that screen right there. Okay, who said that? Let's go ahead and give this man a prize, all right? That was something running, so we have 2 books, it looks like. We have something running out of C downloads right here, okay? And of course it's Dresden, right? So it's our user Dresden, and it's running out of C downloads, and it's lastpass-install.exe. Now, that's not necessarily abnormal. It's just maybe an outlier here, okay? It's running out of downloads. You don't see the installer. Typically, when someone installs something, there's something that you can see, right? But you don't see anything on screen. It's something, it's not necessarily suspicious, but let's take a look at it. So we'll say, let's select all the columns, select star from the processes, where the process ID equals 5908. 5908. And that's going to give us a whole bunch of data that's hard to read. So we can switch output modes. Osquery I has a couple different output modes. We'll say .mode line and rerun that query. makes it a bit easier to read. We have one result, and we can read that a little bit easier. Now, this doesn't give us a whole ton of extra information. We can see that the path, the command line doesn't give us anything, really. Current working directory, we do have the user ID, which I assume is Dresden because it's running out of the Dresden downloads folder. But we also do have the, maybe I have to scroll down a little bit. Do have the parent, there it is right there. We have the parent process ID. So let's go ahead and walk the stack up a little bit. Excuse me, walk it up just one more. We'll say, let's look at the process ID, where was that? Parent is 3088. Okay, so when we look at this, started that LastPass installer. Okay, and that's Explorer. So that means more than likely the user opened up Windows Explorer, went to downloads, and double-clicked the file. And that does tell us something. That tells us that it wasn't running from a services or it wasn't being started from a scheduled task or something like that. So that's valuable information, but it doesn't really give us, at this point, anything else. If we go back and let's requery our LastPass, let's see if LastPass-install started anything. So we check to see what the parent process is. Let's see if it started any processes. We can do that by going to select star from processes where the parent process is the LastPass. If we run that, we see that it started a PowerShell session, okay? And it's running, so PowerShell execution policies bypass, and it's running this PowerShell script, which is a little odd, right? So let's copy this. Let's take a look at what this is. We'll quit out of Osquery. We'll cat and paste that guy. Okay. Yeah, you guys can see that. What do you think? That's looking pretty suspicious, isn't it? Can anybody raise your hand and tell me what's going on there? Yes, sir. Okay, so it's writing to the etc host file. What's it doing? What's this doing over here? So there's a loop. It's checking to see get content. It's checking to see if this portal.office.com is in the etc host file. If it isn't, it adds it or appends it, and then it sleeps for 300 seconds. Okay, definitely malicious, right? So we found something malicious. In summary, we found this installer that apparently spawned a PowerShell session and is sitting in the background looking to see if portal.office.com is in etc host. Now, we can actually confirm. Let's go back. Let's go back and see, is there an etc host table in Osquery so we can confirm this. Now, if you're not sure what tables you currently have access to, you can say .tables, and you could do a search on etc, and that shows you that we have a few different tables with etc in it, and there is an etc host. So if we say select star from etc host, again, if I can spell, run that, and we can confirm that there is an entry in etc host, okay? So that is what's going on. When this user is going to portal.office.com, this is overriding. This is overriding the regular DNS entry, and it's directing them to something else, all right? Now, keep in mind, I think one of the big powers of Osquery is that all the commands I just typed are consistent across all of the platforms that you're running on. So all the stuff I just typed, select star from etc host, all the processes stuff, it's the same whether you're on a Mac OS, Linux, or Windows, which is great because you can never remember, right? If I'm on this platform, what do I use to access this? And so that, I think, is one of the very powerful functions of Osquery. Now, I think we're just about done. How many more minutes do I have? 5 minutes. Thank you. Perfect. Flip back real quick. We have a cheat sheet that I put together. It's available up here. You notice that there are 200 plus tables inside Osquery, right? And so it can be very overwhelming to think through what should I be looking for, how should I use it. So we have a cheat sheet on this page right here. It's process interrogation. We have different techniques as well as queries to run to look at the different processes on your system. On the flip side, we have uncovering persistence with Osquery, and again, it is different tables that you can use to uncover common persistence techniques, and it's mapped to the attack framework and the different techniques that are there, okay? So those are available up here. They're also available at the Applied Network Defense booth. I just recently, last week, released a Osquery class under Chris Andrews' Applied Network Defense at learnosquery.com. You can swing by and get more information as well as pick up the cheat sheet right here, okay? I think that is it. Any questions, comments, or snide remarks? Like usual, yes? What's the daemon used for? Yes, great question. So what's the daemon used for? So you just saw I did interactive stuff, right? Now imagine doing those same exact type of queries across your entire infrastructure. So the daemon is used for you deploy it to all of your hosts. It connects back to a management server. There's both commercial and open source management servers. You schedule queries to run every so often. You can do ad hoc, or you could do scheduled queries. You could say select star from users, and you could run that every 60 seconds. Once that initial data is sent, all users on the system, every time a new user is added to the system, it sends a differential log. So you only get what was added. A new user was added to the system. So that's what the daemon is used for, is to be able to schedule queries and get the log sent back to your manager. And that's what I presented on yesterday at the Security Onion conference, is integrating that data into the network data that we get from Security Onion. Yes? Yes, log format by default is JSON. And it's very, very easy to work through. Yep. Yeah, that's a great question. I haven't seen anything. I've deployed it in production alongside we have a couple different AV solutions, and I haven't seen anything. It certainly could happen at some point, but I haven't seen anything yet. We'll go right here, yes. Yeah, so you have to be careful. The question was, do you get differentials, like for unique PIDs, every time a process is started or something like that? That's where you have to be cautious on how you're writing your queries so that you don't get overwhelmed. If you want that kind of data, then you can select those columns and get. So for instance, there's a listening ports table, okay? So I go ahead and select from the listening ports every 5 minutes on these servers. If there's a new process that starts, I'm certainly going to see that. If there's a new process, depending on how I write the query, I could get a bunch of data, or it could be more limited in scope. Just depends on how you want to look at it. Yes? It is, when I'm deploying it, so it is encrypted through TLS. All of the communication is done through TLS. And I believe it's mutually authenticated, if I remember correctly, with how you can set it up. How am I doing on time? Oh, I have, yes, thank you. 1 minute. Let me do a, I already gave away my answer to one of my questions. Okay, who said the Etsy host file? There you go, your pick, come on down. Pick one of these, and then next question, we'll get the other one. I'm sorry, that's horrible. Yes? It is. Yeah, the question is what kind of impact from a performance perspective does it have on the endpoints? I didn't mention this at the very beginning, but Osquery was built from the ground up to be high performance. It's built to be able to run on your critical production systems. It's also built to be read-only. It does not make state changes to your endpoints in core. You can have extensions that changes the systems, but not in core. And so my understanding is Facebook runs this on millions of hosts. from them is what they say. They run this on large amounts of hosts. So we run it, again, on our critical systems. It is very dependent on the queries you implement and how much data they're sending back, how you're doing joins. Obviously, you can imagine if you're doing some pretty complex subqueries or joins, you're going to get performance issues. And so it's very dependent on that. Osquery does have a very, very active Slack community. And so you can certainly ask those types of questions within there. All right? I think we're out of time. Thank you all so much. Appreciate it.